Hello students, this is unit 3 chapter 2 number theory. So in this one simple questions can be asked for 2 marks. Determine whether 3 divides 7 and whether 3 divides 12. So what you have to do is you have to just check whether 7 is divisible by 3. Now you see when you do this division you will be getting 2.33. That means what you can conclude, this is not exactly divisible. So 7 is not exactly divisible by 3. So therefore you have to write 3 is not divisible by 7. Okay, this is the first one. Second one is the same way. So here it is 12 divided by 3. So 12 is exactly divisible by 3. So you know that it is 4, which is an integer. Therefore, we can conclude 3 divides 12. Okay, very simple. So if you get the fraction, then it is not divisible. If it is a integer what you are getting when you divide, we can conclude that it is exactly divisible. All right, so this is a very simple problem. So we'll move on to the next concept. Now this is about the division algorithm. The division algorithm. This is also a very simple concept. See, this chapter is scoring, very simple it is. So you have to understand this clearly. You take any number, say for example 5, and let us divide it by 2. So 2 how many times? 2 2 times. So what you get? 4. 2 2 times 4. And what is the remainder? 1. So same thing, I'll write using notations here. So this 5 is nothing but A. We call this A as dividend. And you are dividing this 5 by 2. So that 2, here we call this as D. So D means it is divisor. So when you divide this, what are you getting? The quotient there, that top 2 is nothing but the quotient. So quotient we represent using Q. So you will get some number here, and here you will be getting the remainder. Okay, therefore you remember this matter. So A is equal to dq plus r. This is very important. See here A is, you see, with this example if you want to understand the same example what I have written. So 5 is equal to 2 into 2 plus 1, correct? So the same format it follows. So this equation is very important. So you mark this. This equation is very important. Now, two more things are important here. If you want to find the quotient, see quotient, in the problem they may ask you to find the quotients. So you remember this, Q is equal to A division D. So what is A? A and D, you know the same notation. A is the dividend and D is the divisor. So if you want to quotient, you have to write it in this manner. So if you want to find the remainder, sometimes they may ask you to find the remainder. In future it will be of some help. Remainder, the symbol is R. So R is equal to A sorry, it is not divide, it is mod. So here it is mod A mod D. So if quotient is asked, A division D. If remainder is asked, so R is equal to A mod D. All right. Look at the question here. what are the quotient and remainder when 101 is divisible by 11? So what you have to first do is 101 divided by 11, and you know the nearest possible is 9. So here it is 99. So when you do the subtraction, you will be getting the remainder as 2. Okay. So if you write in this manner, A is equal to dq plus r, if you use this, then you see here 101 is equal to 11 into 9 plus 2. But what you are asked to calculate, you are asked to calculate here the quotient and the remainder. So what is the formula for the quotient? Q is equal to A division D, and you are asked to calculate remainder also. So remainder is A mod D. So coming to this, you are asked to find the quotient, right? So quotient, how will you write? You know what is A? A is, see, Q is, you know, just look at the problem there. So this is 9 equal to A. A is 101 division 11. And remainder, if you want, what is the remainder there? It is 2, right? So 2 is equal to 101 mod 11. So this is the quotient, this is the remainder. All right. Now, see the question here. What are the quotient and remainder when minus 11 is divided by 3? So just like the previous problem, we solve this. So the number given is minus 11. So you have to be very careful here. See here, you take this minus 11 divided by 3. See, minus 4 times. So minus 4, when you do, you get minus 12. So 3 into minus 4 is minus 12. Okay. So here you see minus 11, this is minus here. So minus 11 minus of minus 12 is minus 11 plus 12. So what are you getting here? It is 1, because this 12 is a bigger number which is positive. Minus 11 is smaller. So you get here the remainder as 1. So always ensure that the remainder what you get is positive. So you are asked to calculate the quotient and remainder, right? So you know the formula for, what is that formula for quotient? For quotient, you know that Q is equal to A division D. Correct? A division D. So here you see Q is minus 4, A is minus 11, D is 3. So you get here, this is the answer. And the remainder, you see, the remainder, what is the formula for the remainder? That also you know. So R is equal to A mod D. See here, R is 1, A mod D. Okay. So 1 is equal to minus 11 mod 3. Now you see here, one of the common errors that people commit is this. Same problem you see here, minus 11 divided by 3. See, you can also do like this, 3 minus 3 times minus 9. So you will be getting here as minus 3. But problem is, this is, you see here, minus 11 minus of minus 9. So you get here minus 11 plus 9. You get here minus 2. So you see the remainder what you get here is minus 2. So remainder should not be negative. So that you have to take care. So you have to go for that first method what I have done here. So this is one common mistake that everyone does. So you have to be very alert when you solve this type of problem. Now let's see about the modular arithmetic. So here also very easy. Let's say if a and b are integers and m is a positive integer, then a is congruent to b modulo m if m divides a minus b. What do you mean by m divides a minus b? So this implies a minus b divided by m. Okay, so you have to check if you get this as an integer a minus b by m. If it is exactly divisible, you will get an integer. So if it is an integer, then we can say a congruent to b mod m. Okay, otherwise if you are not getting it as an integer, if it is a fraction, then we conclude that a and b are not congruent modulo m. Okay, we'll understand this with one problem. See the question here. Determine whether 17 is congruent to 5 modulo 6 and whether 24 and 14 are congruent modulo 6. That is a two problem actually. So first one, you know what is a is 17, b is a is 17, b is 5, and that modulo m is given as 6. So in this, what we need to do is a minus b you are calculating. So our job is to check this, right? Whether a minus b divided by m is an integer. So what is a minus b? A minus b 17 minus 15, that is 12, divided by m is 6. So 12 by 6 is 2. Okay, it is an integer. Therefore, since 12 is divisible by 6, we conclude that, what is that? See, 17 congruent to 5 modulo 6. Now you see the second problem. In the second problem, you see in the second case, a is given as 24, b is given as 14, m is given as 6. So what you have to do here? Same thing, a minus b by m. So what is a here? 24, b is 14. So 24 minus 14 is 10. Okay, 10 divided by m. M is 6. How much? You get a fraction here. Okay, you get a fraction. So 10 is not exactly divisible by 6. So since 10 is not divisible by 6, we conclude that, you see here, see the symbol 24, this is not congruent. Okay, so 24 not congruent to 14 modulo 6. All right, is this clear? See the question here. This is about arithmetic modulo problems. Use the definition of addition and multiplication in ZM to find 7 plus 11 9, that is addition operation, and 7 dot 11 9, this is the multiplication operation. So both very simple difference between them. Let me divide this page into two, because there are two cases here, right? So first we will solve this 7 addition operation 9. First you should understand the definition of this. What is the definition? The definition of addition here is a plus m b is equal to a plus b mod m. And you see the multiplication operation here, a dot m b is equal to a into b. This is the normal operation, multiplication operation, mod m. See here, we have earlier discussed the, in the beginning of this chapter, I mentioned about the remainder and quotient and remainder. See, wherever there is div, it is the division operation is for quotient. Mod operation is for remainder. So here in you see addition operation as well as the multiplication operation, you find the term mod. That means we have to focus here on the remainder. Now, how are we going to do this? Let's see. See here, A is equal to 7, B is equal to 9, and M is equal to 11. Okay, M is equal to 11. So, what to do? How to solve this? You will see the equation and write 7 plus 11 plus 11, that is the addition operation, 9 is equal to 7 plus 9 mod m. M is 11. So that means this is 7 plus 9 is 16. So 16 mod 11. So 16 mod 11 means what? Mod means what? It is a remainder operation, correct? So what you do is, see here it is 16 divided by 11. Okay, 6 now many times? 1 times 11. So here you get the remainder as 5. So 16 mod 11 means what is it? 5. This is the answer. Okay, in the same way here you see, here A is same 7 and B is 9, M is 11. Same, right? Only thing is operation is different. So 7 dot 11 9 is equal to 7 into 9 mod 11. This is ordinary multiplication. 7 into 9, you know that it is 63. 63 mod 11. So mod 63 mod 11 means what? It is the remainder that you have to calculate, correct? So 63 by 11. 11 how many times? Nearest is 5, right? So 11 5s are 55. Here you have to do the subtraction. So you get the remainder as 8. So 63. See, this mod means it is remainder. Div, division means it is quotient. So here in both the cases we are having mod. Therefore, it is the remainder that you need to do. So this is the answer. Okay, see the next question. Find the prime factorization of the following. So here, first one you see, you are asked to find the prime factorization of this 100. So what you have to do here is 100, you have to start from lowest value, dividing by the lowest value possible. That is, first is 2. So 2 how many times? 50 times. So again you check whether it is going with 2. Yes, it goes with 2 also. So again 25 you get. Now it is not divisible by 2. 50 is not, 25 is not divisible by 2. 25 is not divisible by 3 or 4. Next you see with 5. With 5 it is divisible. It goes 5 times, right? So then you see 2 in 100 is nothing but 2 into 2 into 5 into 5. That is 2 square into 5 square. You can leave it like that. Second problem you see, it is 641. You cannot do anything to 641 because 641 is a prime number. So don't go for any factorization here. You leave it as it is. Third problem you see, it is 999 divided by, whether 999 divisible by 2? No. So you start with 3. Yes, 3, it goes 333 times. Next you see 333 is divisible by 3, 111 times. Next again 111 is divisible by 3. So you get 37, and you see 37 is a prime there. You cannot go further. So 999 is nothing but 3 into 3 into 3 into 37. That is 3 cube into 37. Similarly, other 1024, then one more was there in the notes, 7007. All those things are there in the notes. You can just go through it. I'm just giving you some similar type of problems here. That's all for your understanding. Okay. Look at the next question. Find the greatest common divisor. GCD means greatest common divisor. Okay, this GCD is greatest common divisor of 120 and 500. So what you do, first you take that factorization for 120. So 120, start from the lowest as we discussed in the previous problem. So 120 divided by 2 is 60, 60 divided by 2 is 30, 30 divided by 2 is 15. So 15 cannot be divided by 2, so you check with the next number. So that is 3. So 3 5 times, okay, then 5 is again 5 one time, so only one 5 will be there. So doing that, you look at this, see, 120 is nothing but 2 into 2 into 2, that is 2 cube, into 3 into 5. Keep it as it is. Then you go for the next one, that is this 500. Okay, so 500, again start with the lowest. 500 divided by 2 is 250. 250 goes with the 2, 125. But 125 will not go with the 2, it will not go with 3, it will go with 5. So 5 25 times. So again 25 will go with 5 times, right? So ultimately what you get is this 500 is nothing but 2 into 2, that is 2 square, into 5 into 5 into 5, that is 5 cube. Okay, so this is what we are getting there. Next is very important, how to find the GCD of 120 and 500. Now what you have to do is, see this, what are the three numbers that are involved in 120 and 500? One is 2, another one is 3, another one is 5. Okay, in 500 that 3 is not there, but you still have to write all the numbers which are involved, that is 2, 3 and 5. Here you see, in A it is 2 to the power 3, and in B, that is 500, it is 2 to the power 2. So this 3 is for 120, this 2 is in 500. Same way here also, this 3 is present only for that 120, whereas in 500 that 3 is not present, so you have to write it as 0. Then for 5, you see, in the 120 case, that 5 to the power 1, 5 means 5 to the power 1, whereas in that 500 it is 3. Now what is important is, out of this 3 and 2, what is minimum? Is 2, right? So that 2 you have to write here, 2 to the power 2. Here you see, out of this 1 and 0, what is minimum? Minimum is 0, so that 0 you have to write here. And in the third one, you see, it is minimum value that we have to focus in all this GCD. So what is the minimum here is 1. So 5 to the power 1. So 2 to the power 2 is 4. Then 3 to the power 0 is 1. And 5 to the power 1 is 5. So you get the final answer as, you see, that is 20. So this is the answer. Okay, this is how we find out GCD in a very easy manner. Notes, we have solved this, but still I am explaining here for your understanding faster. So next question is about finding the LCM. LCM means least common multiple. What is the least common multiple of the two numbers as given? So first number what is given is, see, it is a simplified number. Factorization they have done, not like the previous one. Sometimes they may give like this, sometimes they may give us like the previous problem, how we found out GCD, no? So in the same way, so both ways they may give. So now how to do this? Just like the previous problem, how we found out the GCD by writing these powers, you see, in the same way we are going ahead. But only thing was, in the previous case for GCD, it was minimum. Here, what is that? What is the difference? Here it is the maximum. Here it is the maximum. That is the only difference. So here 2 to the power 3 and 4. What is the maximum you have out of 3 and 4? 4. And you see 5 and 3. What is the maximum there? It is 5. And 2 and 0. What is the maximum? This. You don't have to do any simplification. You can stop here. Okay. So comparative, the method is same. Only thing is for GCD, it is minimum. For LCM, it is maximum. Exactly opposite terms. Okay, that's how you should remember. Okay, in the slide you see what is the LCM of 17 and 17 to the power 17, and same number I have considered for finding the GCD also. So you can comparatively analyze this. See, in LCM, what is the method? See, here two numbers are given. 17 means it is 17 to the power 1 actually, and the next one you see 17 1 comma 17 to the power 17 to the power 1 comma 17. So for LCM, what we need to take, we have to take the maximum value, so 17 to the power 17. So next you see, next problem, what is the GCD of 17 and 17 to the power 17? Here 17 to the power 1 comma 17, because the first one is, what is that, 17 to the power 1, no? So minimum value you have to consider here, 17 to the power 1. So when you do this, what are we getting? 17. So LCM is 17 to the power 17. Here it is 17 to the power 1, that is 17 only. Okay, this is there in the notes, so you can check for more problems in the notes. Just a comparative analysis I have done here. So this is another method of finding GCD of two numbers, that is using Euclidean algorithm. Here you see the question, find the GCD of 91 and 287 using the Euclidean algorithm. So you have to follow this method only if it is specifically asked Euclidean algorithm. Now you make a table. So in the first column you find there, you see that quotient. Here it is number A. This is two numbers are given. One is AB. Here it is the remainder. But what you have to do is, first you have to ensure that this number is a bigger number out of the two numbers that are given. See, it is given as 91 and 287. Most of them make mistakes. They write first 91 and then write 287. No, you decide among the two which is bigger one. It is very easy. So under A, you have to write the bigger number, and under B, you have to write the smaller number. If you make this mistake, then the entire problem will fetch you 0 marks. So now what you have to do, 287, see here at the sides I have done that, you see here, 287 divided by this smaller number, that is 91. So 91 3 times, so you get it as 273, and the remainder is 14 here. Okay, so you fill the columns, quotient is 3, remainder is 14. So next what you have to do is, this under smaller number what you had, that 91, that you have to shift here under A. Okay, and this remainder what you had obtained as 14, also you shift it under B. So every time you have to do the shifting. So now 91, you see here, see 91 divided by 14. 14 6 times is 84, so remainder is 7. Next what to do, what is under B, no? This 14, you shift it under A, and this remainder 7, you shift it under B. Again do that. 14 divided by 7 is 2. So you have to go on repeating this till you get this as, till you get the remainder as 0. But here also this 7 you shift it last time. So this 0 you shift it. You have to go on doing this till you get under B 0. So till then you have to go on doing this. Okay, very important. So go on continuing till you get 0 under B. So once you do this, then when you get 0 under B, what is under A, what is remaining there, that is 7. So that is the final answer. That is the, what is that? That is the GCD of given two numbers. So this completes this chapter. So kindly go through it. Very easy chapter. It is scoring also. Okay, thank you.